Today I'll be talking about the topic physics under physics, which is simple harmonic motion. So today I'll be talking on the topic in physics for SS2, which is simple harmonic motion. So firstly, some of you will be wondering what simple harmonic motion is all about, and I will say that simple harmonic motion is a to and fro form of motion. It's a to and fro form of motion, and this type of motion is geared towards a fixed point. So there has to be a point at which that object is placed. So you see, maybe for example it's here and it's connected towards this point, and this is our fixed point. So I say this is a fixed point, and this is where the oscillation now takes place. So if it's a pendulum bob, it moves from here, it passes here, it also moves from here to here, also moves down to this point. So the pendulum was first at equilibrium, then it was displaced. That means there was a form of motion that was applied towards the pendulum, and it moved from that fixed point. From that point, it was at equilibrium to a point, and it also keeps moving and changing direction until it now goes back to rest, which is that same fixed point. So I will tell you firstly that acceleration is directly proportional to x. Acceleration is directly proportional to distance or displacement, and just take note that the acceleration is directly proportional. The acceleration of the moving pendulum, the moving body, is directly proportional to the displacement, and this displacement is taken as x. So if we have a equal to or a is directly proportional to minus x, or a is directly proportional to x, then we can say that a is equal to minus kx. A equal to minus kx, but in simple harmonic motion, the k that we are having is omega square. So that means a is equal to minus omega square x. But the first issue now is that why is this negative sign here? This negative sign implies that it is opposite. It is opposite in direction. It implies that it is opposite in direction from this fixed point where the simple harmonic motion occurs. So it is opposite in direction from the fixed point in which the simple harmonic motion exists. So that's why it is negative. But this minus sign you are seeing here does not really affect anything. So maybe you are solving a question and you are told to find the acceleration. You don't need to go and write minus as the value of acceleration. All you just need to know is that it is a equal to omega square x. But this minus is just trying to tell you the explanation of that. Now we also have different examples or different types of examples of simple harmonic motion. We have the motion of a bulb, just like a simple pendulum, which we're just trying to explain. We have the motion of a mass, which is placed on a spiral spring. So for example, a spring, this is a spring now, and you now come here and place a mass on the spring. Now this also possesses a form of simple harmonic motion. So we have this, a mass placed on a spring possesses, or it takes, or it possesses a simple harmonic motion. That's the first part. So I just explained this. Now we have a equal to minus omega square x, where k is omega square. Now you'll be wondering, what is omega? How does omega, what is omega all about? Omega is your angular velocity, and x is our displacement. This is our displacement. Now I will tell you that in simple harmonic motion, there are certain things we need to take note of. The first one is oscillation. Now oscillation is a term trying to tell us the number of cycles that takes place, talking about moving from here to here, moving from here to here, as if the flow or a complete to and fro motion. That's like a cycle. A cycle in simple harmonic motion is an oscillation, a complete oscillation. Now that's the first thing. Then also we have a distance, which is known as, we have the amplitude. Now this amplitude can be taken as the maximum displacement. I call it the maximum displacement. And amplitude also serves as the radius. It also serves as the radius as well too. So we can say the maximum displacement is known as the amplitude, while the displacement between the equilibrium position and any other two positions, that's the amplitude, the distance between the equilibrium position and any other two position, that's the amplitude. While we also have x, that's from here to here is x, so it's amplitude. then from here to here is x. So we are talking about from here to here now. This place is x, while from here to here is amplitude. That's the first part. Now we have been able to put this together now in the aspect of amplitude. Now I'm going to tell you that there's something called period. Now period is represented as t, and this t implies that t is very synonymous with time. Now I said period is represented as t, and this t is synonymous with time, and the unit of this t you are seeing here now is seconds. Now period is equal to t over n. Now period is t over n, where this t represents time or elapsed time. We can say time elapsed, and over the number of cycles or number of oscillations. So we can just say number of oscillations. That's what this t represents. Then we have f. F is equal to n over t, where n represents the number of oscillations. Then we have t, which is the time elapsed. So we have just observed that that means if t is t over n, f is equal to n over t. It implies that period is equal to 1 over f. So this implies that period is equal to 1 over frequency. So we have been able to establish that period is equal to 1 over frequency. Now the unit of frequency is hertz. The unit of frequency is hertz. So we have frequency, which is hertz. Period is equal to 1 over frequency. Period is equal to 1 over f. Frequency, if period is equal to 1 over f, then you can also get that frequency is equal to 1 over period as well too. So if period is 1 over f, then therefore frequency is also 1 over period. So that's one part. Then also we'll be able to get another formula now to say that we already know that velocity is equal to displacement over time. But in this aspect, now we are going to say, since we are dealing with we are going to be relating something very important, because now we are talking about simple harmonic motion. We can also relate simple harmonic motion to circular motion. So how do we relate it? We're going to be dealing with angular velocity. We're going to be dealing with angular displacement. So now this angular velocity, omega, is equal to theta over t. This theta now represents angular displacement over time. Now this theta now you are seeing here is 2 pi. Is 2 pi radians. Then this t you are seeing here, we are going to replace this t, because in simple harmonic motion we don't use small t, we use big T, which is what? Period. So indirectly we have said that omega is equal to 2 pi over t. But what is the value of frequency? Frequency is 1 over period. So we can relate this to be 2 pi times 1 over t. Now come here, what's 1 over t? That means angular velocity is equal to 2 pi f. So we can say omega is equal to 2 pi f. Omega is equal to 2 pi f. Now we said before that a is equal to minus omega square x. Now I can also tell you that a is equal to omega square x, because this minus is kind of talking about the opposite in direction. That means you can say that a max, we're talking about the maximum acceleration. We're no longer going to be dealing with x again. We're going to be dealing with amplitude, because amplitude is the maximum displacement. I talked about amplitude be the maximum displacement. So in this case, we're going to say a max equal to omega square a amplitude, where a represents the amplitude. So I've just represented that now. So a max equal to omega square a. Then also we have v. V is equal to omega a. Take note, v equal to omega a. So we'll continue. We're going to see how we can express this for you in a simple harmonic motion. So this is our circle. I'm going to draw a circle. Then in this circle, we are going to draw this. I'm going to draw this. Put this here. I'm going to put this here. We're also going to place this here. So, this is our y-axis, because like this is usually the y-axis. then this is our x-axis, then this is a which is equal to radius, because I said amplitude is also equal to radius. Then now this is vo equal to omega a. Then take note that this is angle 90. Then also take note that this is angle 90. All right, then now we are going to work with what we have. So you observe very well, we'll take here as theta. We'll take it as theta. We're also going to take it as theta. So take it as theta. So we're going to observe very well. Firstly, we have a is here. So we have that a using Pythagoras. So using Pythagoras, I don't know if you still remember Pythagoras theorem. Using Pythagoras theorem, we have that a square is equal to x squared plus y squared. So that means that we're going to take this x squared here to give us a squared minus x squared is equal to y squared. So that means we have been able to get y, establish that y is equal to square root of a squared minus x squared. Now if we've been able to get y to be the square root of a squared minus x squared, that's already a plus for us. So we are going to come here and check something very important. Very important. So let's come here and observe what we have here. Now we also need to observe something here, that this is theta, this is opposite, and this is hypotenuse. Now if we are going to be relating opposite and hypotenuse, is sine theta. Sine theta is equal to opposite over hypotenuse. That is so that means this y over a. So if we have sine theta is equal to y over a, we are going to cross multiply, and this will give us a sine theta is equal to y. That's the first part. Now we have gotten the first of all got this 1. Now we have gotten this is 2. Now if we have also gotten this, we can also come here again. Let's come back to this triangle now and observe. Now if this is opposite and this is hypotenuse, what are we going to relate? We are going to relate sine again. Sine theta is equal to opposite, which is a v, then over vo, because vo is the hypotenuse. So that means that vo sine theta is equal to v. That's the other part. Now we've been able to relate this. So we have been able to relate this, and we'll be able to relate this. Now we are also going to check what we already know. But what is vo here? Vo is omega a. So we now come here and write omega a sine theta. V equal to omega a sine theta. Now we have been able to say that v equal to omega a sine theta. But the next thing you are going to ask yourself is, what is a sine theta? A sine theta is y. So that means we are going to have that v equal to omega y. We have come here now, we have been able to get this. This is our theory, v equal to omega y. Now if we be able to get v equal to omega y, the next thing is, what is y? Y is square root of a square minus s square. So we have that v equal to omega square root of a square minus x square. So this is the general equation that is used in simple harmonic motion. The general equation in simple harmonic motion is v equal to omega square root of a square minus x square. That's the general rule that is used in simple harmonic motion. And if you know this, every other thing is very simple for you. So just take note of this, and we are good to go. A question like this, it said if the frequency of a pendulum of length 1.4 meters is 0.43 hertz, 0.43 hertz, the period of the pendulum is. So what we are going to do now, we're giving the parameters, we're giving the length of the pendulum. The length is 1.4 meters. Then we're also giving the length of a pendulum is this. Then we're also giving that the frequency is 0.43 hertz. So what we just need to do is to relate the frequency and period. So you remember that frequency is equal to 1 over period. So you just come here and 1 over 0.43. Now if you use your calculator very well, you observe that 1 over 0.43 will give you 2.32 seconds. 2.32 seconds, and this is 2.32 seconds. So we also have more questions here. We can test this question. Let's try this particular question which we have here. We have the velocity of a simple harmonic motion oscillator, and this is that. So we're already given that v equal to this. So what we'll just do now, just remember that v equal to omega square root of a square minus x square. That's the first part. So we're already given this now. So we're going to compare this to give us 4 square root of 0.25 square minus x square. So if we already have this now, we're going to compare what we have. They gave us find the maximum velocity. So they said we should find v. Then second, they said we should find the acceleration a. So to find v max, we just know that v is equal to omega a. Then secondly, to find a, to find the acceleration, we know that acceleration is equal to omega square a. So what's v here? Compare it. V equal to omega a. So what's omega? Omega is 4. Omega is 4. Then what's a? A is 0.25. 0.25. So that means our answer is 4 times 0.25 will give us what now? Let's check this very well. What's here? We have 0. Okay, this is 0.25. Sorry. So this is not squared. So it is not squared. So that means we need to find a squared equal to 0.25. That means a is equal to 0.5. So we'll come here and use 0.5 here. So this will give us 2 meter per seconds. Then in this place, omega square a. So we already know that omega is 4. 4 times 4 times a, which is 0.25. And this will give us 8 meter per seconds. 8 meter per seconds. Harmonic motion now. We're going to focus our attention on 2 parts now. The part is the mass placed on a spring. Mass placed on a spring. And we're also going to deal with a simple pendulum. So first of all, talk about this simple pendulum. And from there, we'll go to mass placed on a spring. So let's say this is our pendulum. Now, so this is our pendulum. Now this is our length of pendulum, and this is the distance covered. So we'll call this theta. So this is theta. So this is a right angle. So if we're going to relate this, this is opposite and this is hypotenuse. So we have sine theta is equal to x over L. So therefore implies that x is equal to L sine theta. That's the first part. Then also in another way, we can also draw the same diagram. Draw the same. Place this here. Place this here. Place this here. Then take note that if the weight is acting downwards, the reaction is acting upwards. So this will serve as our acceleration. The acceleration to gravity is acting downwards. Then here we serve as our acceleration. So this is theta. You can say that sine theta also, because this is opposite and this is hypotenuse. So we have sine theta is equal to a over g. So indirectly we have that g sine theta is equal to a. So we have this already, that x is equal to L sine theta. Then we have that g sine theta is equal to a. So the next step now is, how do we get a to reflect here? We will now remember that a is equal to omega square x. So meaning that if a is equal to omega square x, therefore implies that we can have that a is equal to omega square L sine theta, because x is L sine theta. So we always equate values. So a equal to a. So we're going to relate this a equal to omega square L sine theta. And we're going to relate it to g sine theta. So from what we have before, we have that omega square L sine theta is equal to a, and a is also equal to g sine theta. And I said in physics we relate quantities. So a equal to a, omega square L sine theta is also equal to g sine theta. Now it therefore implies that sine theta will cancel sine theta. We have that omega square L is equal to g, and omega square is equal to g over L. Then this implies that omega is equal to, no need to write square again, omega is equal to square root of g over L. Then what was omega before? We said omega is equal to 2 pi f, which is square root of g over L. Then this implies that f is equal to 1 over 2 pi square root of g over L. From here, we also know that period is equal to 1 over frequency. Then from there, we can say t period is equal to 2 pi. Instead of 1 over 2 pi, we write 2 pi square root of, instead of writing g over L, we now write L over g. So period, this is period. We have that period is equal to period is equal to 2 pi square root of L over G. And in this case here, we have that frequency is equal to 1 over 2 pi square root of G over L. So these are the formulas. And also when we deal with mass placed on a spring, now in this aspect we are going to just draw the diagram. Now we place the mass there on a spring. Now firstly, we'll go back to what we call Hooke's law. Now Hooke's law states that the force is directly proportional to the extension, and force F is equal to KE. And if F is equal to KE, we also take note that extension is also X, which is also a distance, and this extension X, extension is also X, also distance, so we can change this to be F is equal to KX. Now after doing this, we also remember that force is equal to mass times acceleration. So from here we can now say that MA is equal to KX. Now from there we can say that A is equal to KX over M. So A equal to K over MX. Now we'll now go back to our understanding of simple harmonic motion, that A is always equal to omega square X. So that means A is equal to A, omega square X is equal to K over MX. So that means X cancel X. We have that omega square is equal to what? K over M. And this implies that omega is equal to square root of K over M. And if omega is equal to square root of K over M, we can get that 2 pi F is equal to square root of K over M. And this implies that F is equal to 1 over 2 pi square root of K over M. Then T is equal to 2 pi square root of M over K. Take note of this. If you check very well the factors that affect simple harmonic motion or simple pendulum very well, the factors are glaring at us. The first factor here is we have that F is inversely proportional to the square root of L. So, and the second one is T is directly proportional to the square root of L. So the two factors that affect simple pendulum, the first one is the acceleration due to gravity, and the second one is the length of the pendulum string. So F inversely proportional to the square root of L, and T directly proportional to the square root of L. So take note. So the factors include the length of this pendulum, and the second one is what? The second one is the acceleration due to gravity. Which we just talked about now.